Introduction. An unusual scientific opportunity is about to unfold. The interstellar object 3I Atlas has developed a large ion tail as it nears perihelion. And by coincidence, Hera and Europa Clipper will pass through the downwind region in the coming days. This wasn't planned, but it might allow us to collect the first direct measurements from the tail of an interstellar comet. In this video we'll look at how this opportunity emerged, why it matters scientifically, and what could happen next. Let's get started. Discovery. The interstellar object 3 Atlas is only the third confirmed interstellar object after 1I/Oumuamua and 2I/Borisov, discovered earlier this year. It has been steadily brightening as it approaches its closest point to the Sun on October 29. As solar heating intensifies, the object is releasing gas and forming a long curved tail of ions and water vapor pushed outward by the solar wind. Meanwhile, two missions, Hera and Europa Clipper, are making their way through the solar system. Hera is heading to the Didymos-Dimorphos binary asteroid system to study the aftermath of the DART impact. Europa Clipper is on its way to Europa, Jupiter's icy moon, to explore its potential habitability. Completely by chance, the flight paths of these spacecraft intersect the extended region of 3I Atlas's tail. Hera's observation window is October 25 to November 1. Europa Clipper's observation window is October 30 to November 6. Researchers modeled the tail's trajectory using a tool called Tail Catcher, which incorporates solar wind direction and speed to estimate where ionized material is carried. Based on this model, both spacecraft will pass roughly 8 million kilometers from the central axis of the tail, not close to the nucleus, but within range to encounter dispersed ionized particles. Hera doesn't have instruments capable of detecting plasma or magnetic fields, so its role would be mostly positional, helping refine the geometry of the encounter. Europa Clipper, however, carries a magnetometer and plasma instruments designed to study Europa's environment. These instruments could also detect ions and magnetic field changes caused by the comet's interaction with the solar wind. This opportunity is short-lived, and solar wind variability could shift the tail structure in real time. Even so, the alignment is a rare event, presenting a chance to observe an interstellar object directly with assets already in space. Scientific importance and theories. Interstellar objects offer rare insights into material formed around other stars. Their chemical and physical signatures can reveal what conditions were like in their original systems. So far, every observation of such objects has relied on telescopes. No spacecraft has ever directly sampled their environment. If Europa Clipper records measurements from the ion tail of 3I Atlas, this would represent the first in situ data from an interstellar comet. Even a modest dataset could reveal how its composition compares to comets native to our solar system. The main scientific goals are clear. Ion and plasma characteristics, measuring density, distribution, and energy of tail particles. Magnetic structure, detecting how the comet interacts with the solar wind and how the magnetic field lines are altered. Comparative analysis, determining whether interstellar comets behave differently from local ones in similar solar conditions. This event also provides a way to validate and refine theoretical models. The tail catcher model predicts how solar wind shapes the tail's geometry, but direct measurements have never been made for an interstellar comet. Even a partial dataset would help adjust these models and improve forecasts for future encounters. There are, of course, uncertainties. The spacecraft will be far from the tail's core, so the ion flux may be weak. The tail's position could shift due to changing solar wind conditions. And because neither mission was designed for this event, preparation time is limited. Despite that, even low-resolution data or null detections would provide meaningful scientific constraints. Implications and what's next. If Europa Clipper successfully captures data from this encounter, it would mark a milestone in interstellar research. For the first time, humanity would have direct measurements from the extended environment of an object that originated beyond the solar system. These measurements could refine our understanding of how interstellar comets interact with stellar winds, improve our ability to trace their origins, and inform broader models of planetary system formation. This also underscores the importance of mission flexibility. Neither Hera nor Europa Clipper was built to study interstellar objects. Yet with minimal adjustments, Europa Clipper may collect data valuable to planetary science. This demonstrates how missions can be adapted mid-course to capitalize on unexpected scientific opportunities, something that could become increasingly important as we detect more interstellar visitors. The lessons from this event could shape future missions. The European Space Agency's planned Comet Interceptor is designed to rendezvous with pristine comets or potentially interstellar objects. Real-world measurements from Europa Clipper could guide how such missions are designed, from instrument sensitivity to operational strategies. Time, however, is short. Hera's role will likely remain limited to positional context. Europa Clipper instruments would need to be configured in advance to collect meaningful data during the narrow encounter window. Afterward, scientists would compare the observations with model predictions to refine their understanding of tail dynamics and solar wind interactions. Even if the spacecraft detect nothing, that result would still be valuable. A null detection would establish sensitivity limits for similar future encounters and help calibrate expectations for the next interstellar visitor. This is a rare, unplanned chance to observe an interstellar object up close. If Europa Clipper succeeds, it could yield the first direct measurements from 3I Atlas's tail. Whatever the outcome, it will shape how future encounters with interstellar visitors are approached. Enjoy.